Hello and welcome to the fourth quarter of this school year. So this is our week 7. For this session, our topic will be about geologic hazards. The learning competencies for this session are the following. First, to discuss the different geological hazards. And second, to be able to explain the different types of landslides and sinkholes. Let us start with the different types of geological hazards. Geological hazards are natural phenomena that cause major problems around the world. The expansion and development of cities has led to an increase in impact and damage due to the geological hazards. In general, most of the geological hazards are related to natural conditions, although some may be due to human activities. While landslides come in various names such as mudslide, flash flood, avalanche, and etc., the actual difference is in their composition provided that there is an inclined terrain. Sinkholes, on the other hand, can occur on elevated or flat surfaces and can range from massive to barely noticeable, which may leave a dent or a hole or a body of water on the ground. Therefore, as a student, you need to be aware of the different types of landslides and sinkholes in order to be prepared for the danger that it may impose or cause. Now let us talk about landslide. So a landslide is a ground movement on a sloping terrain. It does not happen on a flat ground because of the angle on the ground. Gravity induces the land to move downward. It is aggravated by rain because water is a natural agent for erosion. And if rain or any source of water frequently flows down a sloping area, the gravitational descent of the loosened soil makes it possible for the landslide to occur. Now, structures that are built on a steep slope mountains have a high vulnerability to landslide and landslide hazards, especially during the heavy rains. Areas with steep slope, a dense population, and denuded terrain are distinguished by a high susceptibility to rainfall-induced landslide hazards. Long or regular rain may saturate the topsoil and the bedrock, which will weaken the soil base of buildings or structures. Without plants and trees whose roots can absorb water and hold the soil together, subsequent rainwater can continue to loosen up the soil that anchors the buildings, and a heavy downpour of rain can quickly destroy these buildings and communities, giving way to landslide, mudslides, or even mud flows. Now let us discuss the different types of landslide. First is the soil creep landslide. It is a very slow downslope movement of particles that occurs in every slope covered with loose and weathered material or materials. Soil creep is a subject of many research studies. Soil creep is the most widespread and perhaps the most poorly understood process of erosion on soil mantled hill slopes. Soil is slowly stirred by burrowing creatures and by growing and uprooting of vegetations. These actions can cause gravity-driven downslope creep by processes that considered to be analogous to particle diffusion. Other possible mechanisms moving soil off a smoothly convex up landslide or landslides include shear and vicious-like creep, such that precise characterization of entire processes appears to require the tracing of labeled soil grains. The second type of landslide is called the slumping landslide. It is a downward movement of rock debris, usually the consequence of removal of buttressing earth at the foot of a slope of unsolidated material. But what do we mean by slumping? A slump is a form of mass wasting that occurs when a coherent mass of loosely consolidated materials or a rock layer moves a short distance down a slope. Movement is characterized by sliding along a concave upward or planar surface. Causes of slumping include earthquake shocks, thorough wetting, freezing and thawing, undercutting, and loading of a slope. The third type of landslide is called the debris flow landslide. This happens when the slope becomes saturated with water. This then triggers a landslide of water-soaked mass of rock and soil that slides down the slope, as being simulated by the file included in this slide. Furthermore, debris flow are geological phenomena in which water-laden masses of soil and fragmented rocks or rock rush down mountain sides, funnel into the stream channels, entrain objects in their paths, and form thick and muddy deposits on valley floors. They generally have a bulk densities comparable to those of a rock avalanches and other types of landslides, but owing to the widespread sediment liquefaction caused by a high pore fluid pressures, and they can flow almost as fluidly as water. Moreover, the breeze flow descending steep channels commonly attain speeds that surpass 10 meters per second or about 36 kilometer an hour or 36 kilometer per hour. So that is the common attained speed of the descending steep channels of the breeze flow. Although some large flows can reach speeds that are much greater than what I have said. The breeze flow with having volumes ranging up to about 100,000 cubic meters, and these occur frequently in mountainous regions worldwide. The largest prehistoric flow that have had volumes exceeding 1 billion cubic meters. As a result of their high sediment concentrations and mobility, the breeze flow can be very destructive. The last type of landslide is called the rockfall landslide. These are sudden slides caused by heavy rain. Then the rock on the slope loosens and then slides down the slope. A rockfall landslide or a rock slide is a type of landslide caused by rock failure in which part of the bedding plane of failure passes through a compacted rock and the material collapses in masses and not in individual blocks. Note that a rock slide is similar to an avalanche because uh, they are both they are both slides of debris that can bury a piece of land. While a landslide occurs when loose dirt of sediment falls down a slope, a rock slide occurs when a solid rock are transported down the slope. The rocks tumble downhill, loosening other rocks on their way and smashing everything in their path. Take note that the fast flowing rock slides or debris slides behave similarly to snow avalanches and are often referred to as rock avalanche or debris avalanche. The next part of our geological hazard is all about sinkholes. A sinkhole is a depression or a hole in the ground caused by some form of collapse of the surface layer. The term is sometimes used to refer to a doline enclosed depressions that are locally known as shake holes, and to openings where surface water enters into the ground or the ground passages known as the ponor or swallow hole. A sea note is a type of sinkhole that exposes groundwater underneath. A sink or stream sink are more general terms for sites that drain surface water, possibly by infiltration into the sediment or crumbled rock. Most sinkholes are caused by chemical dissolution of carbonate rocks, collapse or suffusion processes. Sinkholes are usually circular and may vary in size from tens to hundreds of meters or yards, both in diameter and in depth, and they may vary in form from soil-lined bowls to bedrock in edge chasms. Sinkholes may form gradually or suddenly and are found everywhere in the world. Now let us discuss the different types of sinkholes. First, we have the cover collapse sinkhole. The cover collapse sinkholes or dropouts form where so much soil settles down into the voids in the limestone that the ground surface collapses. The surface collapses may occur abruptly and may cause catastrophic damages. New sinkhole collapses can also form when human activity changes the natural water drainage pattern in karst areas. So in the beginning of a cover collapse sinkhole, the sediments will fall into the cavity, and as the spalling continues, the cohesive covering sediments form a structural arc underneath the ground. Then the cavity migrates upward by progressive loop roof collapse. Then eventually the cavity breaches the ground surface and it will create sudden and dramatic sinkholes. Usually this will develop suddenly over an hour, over a period of an hour, and it will also cause catastrophic damage. The second type of sinkhole is called the cover subsidence sinkhole. It gradually grows where the sediment cover are permeable and contain sand. The cover subsidence sinkholes form where voids in the underlying limestone allow more settling of the soil to create a larger surface depression. So in the beginning of the cover subsidence sinkhole, the granular sediments fall into the secondary openings in the underlying carbonate rocks, and then a column of overlying sediment settles into the vacated spaces. So the process is termed as piping. Then the dissolution and infilling continues, forming a noticeable depression in the land surface. And then eventually, the slow downward erosion will form and a small surface depression 1 inch to several feet in depth and in diameter. It gradually grows where the sediment covers are permeable and may contain sand. The third type of sinkhole is called the dissolution sinkhole. Solution or dissolution sinkholes form when or where water dissolves limestone under a soil covering. Dissolution enlarges natural openings in the rocks, such as joints, fractures, and bedding planes. Soil settles down into the enlarged opening, forming a small depression at the ground surface. So, in the beginning of a dissolution sinkhole, the rainfall and surface water percolate through the joints in the limestone. The dissolved carbonate rock is carried away from the surface and a small depression gradually forms. And then on the exposed carbonate surface, a depression may focus drainage, accelerating the dissolution process. Debris carried into the developing sinkhole may plug the outflow, ponding water, and create wetlands. It occurs in areas where calcium or cal- calcareous is exposed on the ground or where thin layers of soil and permeable sand are also covered. Limestone or dolomite dissolution is most intense when the water first reaches the rock surface. Then lastly, we have the artificial sinkhole. Collapses, or commonly incorrectly labeled as sinkholes, also occur due to human activity, such as the collapse of abandoned mines and salt cavern storage in salt domes in places like Louisiana, Mississippi, and Texas. Most commonly, collapses occur in urban areas due to water main breaks or sewer collapses when old pipes give way. They can also occur from the overpumping and extraction of groundwater and subsurface fluids. Such types of sinks may be caused by various human activities including groundwater pumping and building. Sinkholes can also form when natural water drainage patterns are changed and new water diversion systems are developed. Some sinkholes form when the land surface is changed, such as when industrial and runoff storage of ponds are created, and the substantial weight of new materials can trigger a collapse of the roof of an existing void or a cavity in the subsurface that will eventually result in the development of sinkhole.